Let V be a vector space that is not of infinite dimension. In other words, V can be written as the span of a finite number of vectors. A minimal set of vectors that spans V is called a basis for V. Because a set of vectors is minimal if and only if it's linear independent, we can also define a basis by replacing the word minimal with linear independent. So let's look at an example. And we're going to look at the vector space R3. Now, in R3, every vector is of the form A, B, C, and this can be written as A times 1, 0, 0 plus B times 0, 1, 0 plus C times 0, 0, 1. So immediately, if we take these three vectors, we know that they will span R3. Now, these three vectors are linearly independent because if you consider this equation, the only way you can get the zero vector is to have A equal to B equal to C equal to 0. So the set of these three vectors spans R3 and is linearly independent, and so it's a basis for R3. Now let's look at the vector space of quadratic polynomials in X with real coefficients. And I claim that X squared, X, and 1 form a basis. And it's not too hard to see that this set spans the set of quadratics in X, because if I take A times X squared plus B times X plus C times 1, which is just C, that will give me all possible quadratics in X. Notice that the left-hand side is identically 0 if and only if A, B, and C are 0. And so this is a linear independent set that also spans, and therefore is a basis. Now, there's an important result in linear algebra that we're going to state without proof, and it's the following. Every basis for V has the same number of vectors. And so in R3, no matter what basis you pick, you're going to find 3 vectors. And this number is called the dimension of V, and it's denoted by dim of V. So the dimension of R3 would be 3. And the dimension of quadratics in X is also 3, because this is a basis and there are 3 vectors in it. It can be shown that if you have a set of vectors whose size is larger than the dimension of the vector space, then that set of vectors cannot be linearly independent. So for example, if you are looking at a set of vectors consisting of 4 vectors in R3, then that set cannot be a linearly independent set.